Hi, in this video we will be calculating an inventory reorder point with random demand. If there is no randomness, life is simple, and we set the reorder point equal to the demand per day, lowercase d, times the lead time in days, L. So when we have 5 days worth, place an order if the lead time is 5 days. But if there is randomness, then we need to add in this additional amount here, which we can call the safety stock. The additional inventory that we are going to hold on to just to make sure that we don't run out. Now, D times L, that's easy to calculate. The safety stock, however, depends on 3 factors. Starting at the back here, the standard deviation is the standard deviation per day. D is the demand per day, sigma is the standard deviation per day. Then we have the square root of the lead time, and only the L is inside that square root symbol. And those two together represent the standard deviation of the demand over the lead time. And then we need Z, which is the number of standard deviations that, that we should set the safety stock at. And on this formula, the way we are doing that is we are taking as an input the probability of not running out. So in of the ordering cycles, when we order more, then we order more, out of all those ordering cycles, on average, 98% of the time, we will not run out. So how do we take this probability, 98%, and arrive at a Z value? We need a standard normal table. And if I had better video editing skills, I would just make like a page appear from a textbook, but I don't. So, if you think about a standard normal table from a textbook, you've got the standard normal curve, and then you've got the area under it, and you tell me a Z value, and this table, which some books would call capital F of Z, might be something else. That is the total area under the curve. And we want the total area under the curve, in our case, to be 98. So we're looking, so 90, 93, 94, 95, 96, 97. Here we go, 98. So we want a Z value of 2.05. So we will say Z equals 2.05. And our calculation then will be the reorder point equals D times L. D is 40 and L is 5 plus Z, and we just decided Z is 2.05 times the square root of L. Now, the square root of L is, in this case, the square root of 5 is 2.24, yeah, 2.24. So the square root of 5 is 2.24. So we have 2.25 times 2.24 times then our standard deviation per day, which is 10. Okay, so multiplying this out, 40 times 5, obviously that's 200. The rest of this works out to 45.8. So our reorder point is the sum of those, so 248, but we have, you could say 200, this is the amount we sell on average, the amount we expect to use. And some people will refer to that as our cycle stock, the amount we expect to go through, to turn through every time. And then the 48 units, that is our safety stock, which on average, you could argue we don't use. But half the time, our inventory is less than 200, our demand while we wait for the order to arrive, half the time the demand is less than 200, and half the time it's more than 200. So half the time, we're going to dip into this safety stock. So just to summarize here, when we have random demand, and we are assuming, in this case, normally distributed, we have the average per day and the standard deviation per day, and we are given the probability of not running out that we would like to achieve. So based on that probability, we look in the standard normal table and we were looking for a probability of not running out of 98. So we looked for the total area under the curve to be 0.98, and we found that here in this row where z is equal to 2.05. So we use 2.05 as our z value, and the reorder point is the demand per day times the lead time, dl, plus z of 2.05 times the square root of the lead time, so the square root of 5 multiplied by the standard deviation per day, 10, and that gave us 248, of which 200 is cycle stock and 48 is safety stock. I hope this has been helpful.